Why does the word cosmic boundary make so many frameworks flinch? As if you just asked a forbidden question. In the energy filament theory, the reason is simple. Most traditional boundary pictures treat the edge like a geometric object, a wall or a shell. And that instantly triggers 4 clusters of problems. This picture avoids them by making the boundary a relative threshold in a medium, not a hard thing in space. Problem cluster 1 is the center and privilege trap. The moment you draw a finite ball, you automatically create a geometric center. And if the boundary isn't unimaginably far, looking in different directions means different distances to the edge. In many mainstream stories about the CMB, large-scale structure, and redshift, that would tend to create directional residuals. So you either push the boundary so far you can't see it, or you quietly accept that we happen to be near the center. That's the privilege problem. In this picture, the boundary is not a painted sphere. It's where propagation breaks down because the sea becomes too loose. The energy sea can be irregular in shape. So yes, it can have a trivial geometric middle like any finite object, but it has no dynamical center and no measurable effect that labels a special universe center. Isotropy is treated as a statistical property of the sea state window we live in, not a declaration that the entire cosmos must be identical everywhere. Problem cluster 2 is the reflection and bookkeeping trap. If the boundary is a wall, you must answer, does light reflect? How much is absorbed? Where does the energy go? What happens to background radiation? And why doesn't the wall create echoes and artifacts? If you pick the wrong boundary conditions, you collide with observations and end up fine-tuning. In this picture, there is no wall. Propagation is a relay in a medium. And when relay fails, disturbances don't bounce, they dissipate and lose coherence. There is no free reflectivity knob you can tune. The transition belt also makes building a wall out there unrealistic. Particles struggle to self-stabilize as you approach the threshold. So there isn't even good material to stack into a hard shell. Problem cluster 3 is the dynamics trap. And it's often a side effect of a model choice. If you lock redshift into geometric expansion and treat it like a recession speed, then adding a boundary forces you into awkward questions. How does the boundary move with the scaling factor? Does that motion leave signals? Does the edge race away? Does it rebound? That mess is not guaranteed by the existence of a boundary. It's the cost of forcing redshift to be primarily a geometric motion label. In the energy sea picture, redshift is read mainly as a ratio of rhythms and yardsticks across time. So the universe does not need to carry a dramatic global space-running dynamic. The boundary is a sea-conditioned threshold band that can drift slowly as relaxation continues, without dragging a huge expansion engine behind it. Problem cluster 4 is the epistemology bottomless pit. What is outside the boundary can spiral into what's outside that, forever. But notice the symmetry. If you claim the universe is infinite, you can still be asked why infinite. If you claim it is finite but unbounded, you can still be asked why that math. Those chains never end. In this picture, relay failure gives you a clean physical stop sign. If the propagation chain is broken, then whatever is outside is causally isolated from us. It cannot send influence or information back in a continuous way. You can allow a restrained speculation that far away there could be other energy lumps with other boundary conditions. But that speculation is not needed for the boundaries inside our seas to be a real physical threshold. The punchline is simple. Traditional boundaries feel like a taboo because they are written as geometric objects, which immediately triggers privileges, reflection, dynamics, and infinite regress. A relative threshold boundary avoids the first 3 by changing the ontology, and it tames the 4th by making outside physically irrelevant to inside, at least in terms of exchange and influence. Next episode we flip it into a challenge. If the boundary is a threshold band and not a wall, what single observational signature would be hardest for geometry-only stories to fake, and easiest for a relay failure story to predict? Tap follow, share it on New Physics, Clear Universe.